All right, let's get right into it. One of the biggest hurdles for any programmer isn't just solving a problem one time. It's figuring out how to solve it 100, 1,000, maybe even 1,000,000 times. How do you deal with all that repetition without losing your mind? Well, that's exactly what we're going to break down right now.
So, here's the big question. How do you make that leap from a beginner who just, copies and pastes code over and over again to a pro who can automate just about anything? The secret, really, is mastering the engine of computation, the loop. This is where you unlock some serious power in your programs.
And this slide just says it all, doesn't it? On the left, you've got the hard way. Manually writing out a print statement for every single number. Sure, it works for 4 numbers, but imagine trying to do that for 1,000. What a pain! But then, look at the right, the smart way. A clean, simple for loop that does the exact same thing in just 2 lines of code. That's the kind of elegance we're talking about.
Okay, so let's kick things off with our most common tool, the for loop. This is going to be your go-to solution for any problem where you know exactly how many times you need to repeat something. Just think of it like taking a road trip where you already know the destination and all the stops along the way.
Now let's get our terms straight, because this is super important. A for loop is what we call a control flow statement. Basically, it runs a block of code, that's the indented part, a specific number of times. That little x is our loop variable, and it's going to change with each pass through the loop. And each one of those passes, we call that an iteration.
So what's actually happening inside that range of 4? Well, on the very first iteration, x is set to 0. Then, on the next pass, x becomes 1, then 2, and finally 3. Now here's the part you've got to remember. Range is exclusive. It goes up to but does not include that final number. So range of 4 gives us 4 numbers total: 0, 1, 2, and 3.
All right, time for a little bug hunt. On the screen is a function that's supposed to calculate a factorial, but it's totally broken. No matter what number you give it, it just spits out 0. Take a look. Why is that happening? Can you spot the bug?
And there it is. The culprit is that range of 5 starts at 0. So on the very first trip through that loop, our total gets multiplied by 0. And once that happens, it's game over. You can multiply it by 1,000,000 after that, but the answer will always be 0. It's a classic programming trap.
So, how do we fix it? It's actually a pretty simple fix. We just give the range function a starting number. See, range of 1, 5 tells the loop, hey, start counting at 1 and go up to, but don't include 5. So it'll loop through 1, 2, 3, and 4. And just like that, we've neatly sidestepped that whole multiplying by 0 problem.
Okay, now we're getting into the really cool stuff. What happens when you need to repeat a repetition? For that, we turn to nested loops. This is how you start solving more complex problems, like working with grids or generating combinations of things.
Let's trace this one step by step. First, we hit the outer loop, and our variable x gets set to 0. Now, here's the critical thing to understand. Before x gets another turn, the entire inner loop has to run from start to finish.
So we dive into that inner loop. The variable y starts its journey at 0, and boom, our code prints the very first coordinate. X is 0, and y is 0.
And just watch. X stays frozen at 0 while that inner loop just keeps on chugging. Y becomes 1. We print 0, 1. Then y becomes 2. We print 0, 2. And that's it for the inner loop, for now.
Okay, now that the inner loop is done, control finally goes back to the outer loop. It's ready for its second and final iteration, so x gets updated to 1. And what do you think happens next? You got it. The inner loop starts all over again, right from the beginning. But this time, x is held constant at 1, so y iterates through 0, 1, and 2, printing out 1, 0, 1, 1, and 1, 2. This relationship, where the inner loop completes its full run for each single step of the outer loop, is absolutely fundamental.
So, for loops are awesome when you know exactly how many times you need to loop. But what if you don't? What if you need to keep asking for user input until they type quit? Or maybe you need to monitor a sensor until its reading crosses a certain value. For those kinds of jobs, we need a different tool, the while loop.
Look, here's the bottom line. It's all about picking the right tool for the job. You gram a for loop when you're dealing with a definite number of things, like going through every single item in a list. You use a while loop when you have no idea how long you'll be looping, and you just need to keep going until some condition becomes true.
So here's a classic while loop scenario.
We keep asking for numbers and adding them up until the total gets over 100. But look closely at that int function. What do you think happens if a user decides to be tricky and types in a number with a decimal, like 18.3?
And surprise, it crashes. This is one of those subtle little gotchas in Python that trips up so many developers. You see, the int function knows how to handle a floating point number. It just cuts off the decimal, so int of 18.3 becomes 18. But it has no idea how to parse a string that has a decimal point in it. That int of 18.3 raises an error. It's a perfect example of why thinking about user input and errors is so important for writing real-world code.
So we've covered the big two, for and while, but sometimes you need even more control inside your loop. What if you need to bail out early? Or what if you just want to skip over the rest of the code in the current iteration and jump to the next one? For that, we've got two special commands, break and continue.
Getting the difference between these two is absolutely crucial. Break is like hitting the big red emergency stop button. The second your code hits a break statement, the loop is done. Finito. Continue is much more polite. It just says, okay, I'm done with this particular iteration. Let's just jump back to the top and start the next one.
I love this slide because it shows the evolution of writing good code. In the first column, we're using continue to skip the even numbers. It works, so it's good. The second option is a little clearer, a little more direct, so better. But the best option, the most elegant, the most Pythonic, is the third one. It uses the step argument and range to only generate odd numbers in the first place. No extra logic needed inside the loop. That is what clean code looks like.
And this is a piece of professional advice you really want to remember. Break and continue are definitely useful tools to have, but they can make your code really hard to follow if you overuse them. If you find yourself sprinkling them all over your loops, it's probably a sign that there's a simpler, cleaner way to write it. So use them, but use them sparingly.
Okay, let's do a quick recap of your loop toolkit. For loops are for when you know exactly how many times you need to iterate. While loops are for when you need to keep going until a certain condition is met. Nested loops are your secret weapon for handling complex grid-like patterns. And finally, break and continue are the precision tools you pull out for that extra bit of control.
In the end, loops are so much more than just a piece of syntax. They are the engine that drives almost all of modern computation, from the simplest script to the most complex artificial intelligence. They're what let us use the incredible speed of a computer to do things humans could never do manually. So the only real question left is, now that you have this power, what are you going to build with it?